Friends, I am Vikash Kumar. Welcome to this master training session on MLFF subsystems. MLFF stands for Multi-Lane Free Flow Tolling System. The objective of this system is to collect tolls without stopping vehicles, without barriers, and without creating traffic congestion. The success of any MLFF project depends on its different subsystems. Every subsystem has a specific role. Some subsystems identify vehicles, some capture vehicle number plates, some detect and classify vehicles, while others manage the complete network, storage, communication, and monitoring infrastructure. If we compare the MLFF system to the human body, every subsystem functions like an important organ. If even one critical subsystem fails to perform properly, toll transaction accuracy and revenue collection can both be affected. That is why the RFP document defines minimum technical specifications for every subsystem to ensure uniformity, reliability, and high availability across the entire MLFF ecosystem. In this session, we will understand all the major subsystems used in an MLFF project, learn their minimum technical specifications, and understand the exact role each subsystem performs. The major subsystems in an MLFF project are RFID reader, RFID antenna, audit surveillance camera, ANPR system, IR illuminator, LiDAR detector, radar detector, local server, storage system, monitoring workstation, firewall, server rack, field junction box, edge level switch, core switch, enterprise management system (EMS), video wall controller, PTZ camera for plaza and gantry surveillance. All these subsystems work together to create an integrated MLFF toll collection ecosystem. Now, let's understand each subsystem one by one, explore its minimum technical specifications, and learn the exact role it performs within an MLFF project. Let's begin with the first and most important subsystem. RFID reader. The RFID reader is the primary vehicle identification device in the MLFF system. Whenever a vehicle passes beneath the gantry, the RFID reader detects and reads the vehicle's FAS tag. It captures the unique tag ID stored inside the FAS tag and forwards this information to the transaction processing system. Based on this data, the vehicle is identified and the toll transaction is initiated. Minimum technical specifications. Protocol EPC Gen 2 ISO 1800006 compliant. Frequency 865-868 MHz. Speed support 100 kmph or higher. Antenna ports 4 ports. Memory up to 10 lakh transactions. Communication Ethernet, RS-232, USB. Protection rating, IP65. Operating temperature, -10 degrees Celsius to +55 degrees Celsius. What does the RFID reader do? The RFID reader performs the first and most important step in the MLFF transaction process. When a vehicle passes beneath the gantry, the RFID reader detects the FAS tag, reads the unique tag ID, identifies the vehicle, sends the tag ID to the transaction processing system, initiates the toll transaction. How the RFID reader works. Step 8. The vehicle enters beneath the MLFF gantry. Step 2. The RFID antenna transmits radio frequency signals. Step 3. The vehicle's FAS tag becomes active. Step 4. the RFID reader reads the unique FAS tag ID. Step 5. The tag ID is transmitted to the transaction processing system. Step 6. The system identifies the vehicle and initiates the toll transaction. Role in the MLFF system. The RFID reader serves as the primary vehicle identification subsystem. It identifies vehicles through FAS tag, starts the toll transaction process, communicates with the backend system, supports high-speed vehicle movement, enables barrier-free toll collection. Why is the RFID reader important? Without the RFID reader, the MLFF system cannot automatically identify FASTag-equipped vehicles. If the RFID reader fails, FAS tag cannot be read. Vehicle identification fails. Toll transactions cannot be initiated automatically. Revenue collection may be affected. That is why the RFID reader is considered the foundation of the MLFF toll collection process. Practical example. Suppose a vehicle equipped with a FAS tag passes beneath the gantry at a speed of 100 km/h. In this situation, the RFID reader detects the FAS tag. The unique tag ID is read successfully. The data is sent to the transaction processing system. The vehicle is identified. The toll transaction is initiated automatically without stopping the vehicle. This entire process takes place within a fraction of a second. Key features. The RFID reader is designed to support high-speed vehicle identification, multi-lane tolling operations, FASTag-based automatic identification, reliable communication with backend systems, large transaction storage capacity, outdoor operation with IPMSAT protection. Key takeaways. RFID reader is the primary vehicle identification device. It reads the FAS tag installed on the vehicle. It captures the unique tag ID. It initiates the toll transaction. It supports vehicle speeds of 100 km/h or higher. It is an IP65 rated outdoor device. Next subsystem. DO. RFID antenna. In the next section, we will understand how the RFID antenna establishes radio communication with the FAS tag, creates the RFID detection zone, and ensures accurate FAS tag reading for high-speed vehicles.